Thank you very much for joining our workshop. Today's topic is about the challenges of fracture, VAG, and cast modeling and simulation. My name is Jiju Miao. I'm serving as the CEO at Semtech, and I will be your moderator for today's workshop. It's our great honor to co-host this workshop with Dr. Kamy Sepehrnoori from University of Texas at Austin. Actually, we were talking about this workshop for a long time with different companies. Obviously, this topic is a major challenge to many people, and we've got big support from many companies and our partners. Today, we are very fortunate to invite two special guests from Petrobras and ExxonMobil. They are Dr. Sergio Cavalcada and Dr. Brightup. And my colleagues, Dr. Yue, Sir Joseph, and Mauricio, we appreciate their awareness and efforts to share their study with us today. I hope you all enjoy the talks and share your ideas with us as well. Here is today's agenda. Today's agenda includes 6 talks, and it's expected to last 5 hours with 2 breaks. Here I'd like to stress the break is from 9:50 to 9:55 to 10:55. So it will last 1 hour. And the second break will be from 12:10 to 12:40. Please be noted, the second break is 30 minutes. Except the opening talk, there will be 10 minutes question and answer time for each talk. Our workshop could be accessed by both Zoom and Teams. Here is a brief meeting guideline. All audience will be on
recording in progress.
Yes. Please. So here is a brief intro meeting guideline. All audience will be automatically muted during talk. Please use the chat box for any questions, as the questions will be answered during question and answer session after each presentation. You may use the raise hand option under that if you want to directly communicate with the presenters during the question session. And we had faced the issue of being kicked out during testing. Please join back the meeting in case you will face the same issues. This meeting is recorded for some sessions and will be available under all the speakers' consent. So some the talks will not be recorded, and if you are interested about try to access to the recording, you can contact us later on. So let's straight to the first talk. Dr. Kamy Sepehrnoori, who is our first speaker and our co-host. He is a professor in the Hillbred Department of Petroleum and Geosystem Engineering at the University of Texas at Austin. He has been teaching there for over 35 years, and he has graduated more than 230 master and PhD students. He has published over 600 articles, more than 600 articles. Dr. Kamy Sepehrnoori is the director of Reservoir Simulation Joint Industry Project in the Center for Subsurface Energy and the Environment. For the last several years, we are very lucky to have him as a senior advisor to lead our collaborative research in fracture reservoir simulation and Semtech. Let's welcome Dr. Kamy Sepehrnoori to give the opening talk. So, Professor, I will stop sharing.
Ladies and gentlemen, good morning. Thank you very much, Dr. Miao, for the introduction. And as indicated, today we are going to have a workshop on the embedded discrete fracture as related to WOGs, karst, and open fractures. And I'm sorry for the this problem we had at the beginning, but we try to catch up. Next. Can we go to the next slide? Okay, basically, in the area of fractures and vogs and modeling, there are really a lot of different challenges. To start with, this is a multi-scale problem because we're talking about fractures that they are very small in comparison to vogs and cars. And as far as I know, based on the literature, we are not aware of any reservoir simulator that has a capability to handle basically vogs and cars in a meaningful manner. None of the commercial simulators that we are aware of. Characterization and validation of such simulators are not a simple task. One of the areas that we have been working on quite a bit is in the area of acidizing in carbonate reservoirs. And in carbonate reservoirs, as you know that when you actually use acidizing, you create wormholes. And they are, in a sense, they are similar to channels or similar to cars, but in a very small manner, okay? Computational efficiency becomes an issue in this regards when you're doing such a modeling, and history matching and production scenarios also is a challenge. Next. Before I go further, I just wanted to describe the relation that RSJIP from the University of Texas at Austin in the Department of Petroleum, Hildebrand Department of Petroleum and Geosystem Engineering with Semtech. We've been conducting research in the JIP called reservoir simulation for many, many, many years. In 2017, when Semtech got initiated, we became a team in a sense that, and one of the reasons was that at the University of Texas, we are doing very different types of research in area of petroleum engineering and reservoir simulation. However, the work that we are doing at the university is of fundamental nature. And in order to translate that technology, that it be usable by the industry, we teamed up with Semtech, and some of the software, some of the theories that we develop, it's nourished by Semtech LLC, and it makes it usable that it can be used by the engineers at the industry level. So this has been working out very well because in a sense is that LLC or the Semtech LLC is dedicated to commercialization of some of the development that we are performing in the reservoir simulation JIP. Next. Very quickly, the RSJIP group at the University of Texas at Austin is possibly the largest reservoir simulation group in the US and one of the largest in the world, because number-wise, we do not compete with the Chinese universities because they have hundreds of students that they can work and employ in various areas. But as you can see there, on the first column, we have shown some of the professional people, advisor, research associates that they're involved in this JIP. In the second column, we are showing the PhD candidates that there are many. And in the third column shows the MS candidates that they are working or have been working in this area. The asterisk with the red asterisk next to it shows some of the students that they graduated this year. Next. Some of the key research areas that we're involved with, we are doing development of various simulators. I'm going to say a little bit more about it. Two famous codes called UTKM and UTKMRS. These are the codes that we've been evolved, and now we talk about UTKMRS and UTKMRS. And these are the field type simulators that we have basically produced from the original code UTKM and UTKM. We do quite a bit of work in natural fracture reservoir development. We do quite a bit of work in basically high performance computing. I'm going to say briefly a little bit about that. We've done a lot of work in the area of low salinity water flooding, macrogel for profile control, phase behavior, quite a bit of work that is not going to be described today in the area of flow assurance, asphaltene scales, and that type of things, head rates, okay? Quite a bit of work is being performed in the area of compositional reservoir simulation. Today, we're going to be talking about embedded discrete fracture model that relates to unconventional reservoir simulation. Areas of work that we have started looking at WOGs and crust modeling, and related to acidizing, CO2 sequestration, hydrogen storage, and geothermal energy. If anybody's interested for description of some of those other research areas, please let me know and I'd be happy to contact you. Next. One of the work that we are doing at this point is that we are working on a multi-purpose reservoir simulator, which is called MPS Code. And in MPS Code, basically I mentioned about UTKMRS, UTKMRS. All of these codes, they're going to go under this umbrella that we will have immiscible gas flooding, chemical flooding, thermal flooding. And this simulator will have a very easy, user-friendly input-output. These are connected to the graphics. And as you can see there, a lot of physics goes into this simulator. Matrix acidizing, flow assurance, geochemistry, geomechanics, and is connected to a compositional wellbore. Also, it has capability of history matching and using all types of facilities for the user in order to carry out the simulations. Next. I mentioned about UTKMRS, that this is a chemical flooding simulator that is going to go under MPS code. It has been updated from the original code UTKM, and basically this code has a capabilities that you can do field scale simulation. It has impact formulation, full implicit formulation, adaptive implicit formulation, as well as quite a bit of other facilities for high order approximation, as well as capability to handle fractures. Next. UTKMRS is the next code that, again, that is we are using for miscible gas flooding. Quite a bit of work has been done in that. There are some features in this code that they do not exist in some of the reservoir simulator that they marketed as a commercial simulator. Once again, this code comes from a UTKM code, but it has recent capabilities of doing fully implicit, adaptive implicit, and running large scale simulation as much as of millions of simulation. Good blocks. Next. Doing quite a bit of work in the area of parallel processing. The plan is that all of this code will have capabilities. We have basically codes that they are based on what I discussed, UTKMRS and UTKMRS, but we have done work in this area that basically we have moved this to a parallel framework. It hasn't been released yet, but we are looking at parallel processing as well as GPUs for our future types of simulation. A paper was published that it showed that we use 500 million grid block. We can go as much as larger than that depending on the number of processors you have. The number of processors that they use for the 500 million grid block was over 4,000. Next. Today, we're going to talk about embedded discrete fracture model, application of this model into WOG and karst in a specific. And in a nutshell, what it is that we started this research over 10 years ago. And instead of using discrete fracture modeling, that we did some of that work, but it was computationally very expensive, we went to a fracture in the embedded discrete fracture model. So we are using double gridding, one for the base, which represents the matrix, and then one for the fractures, and these are superimposed together. You're going to hear a lot about this, and I'm going to let other people to go over description of this technology. Next. We have applied this embedded discrete fracture model to various applications in water flooding. We've done it for basically for the matrix acidizing in the carbonate reservoirs. And we've done it for the first application that was done for the fishbone in Austin chalk. We were contacted by several companies. We modeled this. The technology essentially is that, as you can see there, that in the wellbore, you have these nozzles, they come out and then they spray acid, and they make holes that they are up to 40, 42 feet. And the diameter, it's about, the opening is about ½ an inch or so. And we've done some of that work. Quite a bit of work has been in this area. And in all of these, we have papers. If you're interested, we'd be happy to share. Next. The latest work that we've been doing has been in WOGs and acidizing. And this leads into some of the work that is going to be described in EDFM approach. And we have presented this, that we're talking about how acid is going to be penetrated and it moves in the WOGs. And it leads into some modeling that it may not be valid to basically use Darcy flow, because these are openings, they're holes, and the modeling is going to be quite different. So some of the work that is going to be presented today, we're going to be presenting the WOGs and cars, but the other type of work that we're not going to basically present today, that maybe in a future meeting we'll be discussing, will be that how do you use this stuff in an actual simulator? And the simulator needs to be adapted to actually simulate such formations. Next. Wanted to bring to your attention, starting 2017 to 2021, we've written 4 books in here. One on low salinity water flooding, which is not really related to the work that we're talking about today, but the work on shale gas and tight oil reservoir simulation. Entire book, which was published in 2020, was on embedded discrete fracture, and a new book that is on assisted history matching. It will be published in about 4 months because it's been submitted to the publisher. I urge you to take a look at some of these that it relates to what we are discussing today. Next. Would like to thank everybody for attending this meeting, and I hope we all have a very good meeting in the next 4 hours or so. And I will be around for the entire meeting. During the break, I will be happy to talk to anyone who is interested. Thank you very much for your attention.